Let's first talk about the definition of the absolute convergent and conditionally convergent. A series, the sum of a sub n, is called absolute convergent if there is a series. If the series of the absolute value, the sum of absolute value of a sub n is convergent. Conditionally convergent. If a series called conditionally convergent, if it's convergent but not absolutely convergent. What does it mean? It meant that the sum of a sub n is convergent, but the sum of the absolute value of a sub n is not converge or diverge. Is divergent. Yeah. So if the series a sub n is absolutely convergent, then this is converged. Determine whether the series is convergent or divergent. We have the sum from n equal 1 to infinity of this alternated series. When n equal 1, we start with negative 1. When n equal 2, plus 1 over 2 squared, minus 1 over 3 squared, plus 1 over 4 squared, and this is so on and so forth. Let's take a look at the absolute value. N equal 1 to infinity of the absolute value of a sub n. So this is 1 over n squared. Or you can start with negative 1 to the n. This equals the sum of n equal 1 to infinity of 1 over n squared. This is a convergence P series. Okay. And so since this series with the absolute value convergent, then here I can say that, okay, therefore, the sum from n equal 1 to infinity of negative 1 to the n divided by n squared is absolutely convergent. So this happened a lot with alternating series. So one thing about alternating series from the previous section that we add in this time is an alternating series can be absolute convergent or absolutely convergent or divergent or conditionally convergent. Okay. And you have to check. Now, in the next case, let's take a look at our first couple terms. So here we have the term being 1 minus 1 to the second, 1 over 2 to the second, plus 1 over 3 to the second, minus 1 over 4 to the second. Not to the second, this is just n at the denominator, right? So that is 2, 3, 4, so on and so forth. Now, we know that this is a convergent alternating series. This is a convergent alternating series. But is it absolutely converged? So let's take a look. This is diverged. Again by p-series. So this meant that the alternating series n equal 1 to infinity of -1 to the n minus 1 divided by n is only conditionally convergent. Conditionally converge. So you can see the difference in two cases. In the first case, you have is absolutely converge. And then in the second case, you have conditionally converge. So here, let's take a look at this series. The sum of n equal 1 to infinity, the cosine of n divided by n squared. So let's write out the first couple terms. You get cosine of 1 divided by 1 plus cosine of 2 divided by 2 squared plus cosine of 3 divided by 3 squared plus so on and so forth. Now remember, cosine of n is alternating between -1 and 1. This implies that the absolute value of cosine of n is less than or equal to 1. So if I want to compare this, I can see that, well, this is the case, then the absolute value of cosine of n divided by n squared is going to be less than or equal 1 over n squared. I know that the series of n equal 1 to infinity of 1 over n squared is converged. So this then implies that the sum from n equal 1 to infinity, the absolute value of cosine of n divided by n squared, n is always positive. That's why I don't extend the absolute value to the denominator. It doesn't matter if you do. Then this is convergent, right? So this is converged by the comparison theorem. By comparison. Yes. Okay. So then this meant this series here, the series that you're given, n equal 1 to infinity, the cosine of n divided by n squared is convergent. Okay, and this is absolutely convergent. It is absolutely converged.